Well, hello everybody. Oh, focus on my face. Can I get it? Can I get it? Let's see if it's gonna do that again. Hi everybody, welcome. Oh, my audio looks to be a little hot. Let's see how that works. Yeah, let's see. Is it working? I don't want to yell too much. All right, so Mason's in the office, so he'll let me know if it's working. I think I need to adjust my bit rate. So let me see if I don't think I can do that on the fly. Output stream. Oh yeah, bit rate's way too low. All right, the audio's a little echoey, so let me. Did that work? Okay. Oh, wow, you can adjust the bitrate on the fly. That's crazy. Let's see if that works. Okay. Audio is echoey. I don't know. Let's see, where would that be coming from? Is there just one source? Let's pull up the audio levels. So the context here is, oh yeah, first of all, I need to think it sounds okay now. Okay. It's quiet? Oh, because it looks like I'm peaking on my side. All right. So yeah, let me know, folks, if this is working. Good evening, Valgrind. How's it going? Sorry, I'm a little behind, especially for those of you in Europe. It's going to be a little late stream. I've been trying to get them earlier. You'll notice last week was a little bit earlier. It's also nice for me, so I get a more of a weekend. This is going to be something different, as I advertised on. Ooh, I can make sure that went to Slack too. Let's see. Yeah, let me post to Slack real quick. All right, so let people in Slack know audio is Ruby. Yeah, hold on. Let me make sure. I think it's coming from the oh. Testing, testing. All right, so I switched. I don't know if that's it though. I think it's the same. Oh, I should just monitor it. Let me pull this up. I can monitor it locally. If this is the only thing I gotta fix, I will be. What's that? Oh, is it better now? Let me see. Much better. Sweet. All right, monitor. Testing. Okay, now I can hear myself. Yeah, that was probably just. Actually, I don't even know what it would have been recording from. The webcam? Oh, probably the webcam. All right. Sweet. All right. I don't hear myself. Okay. Well, thanks everybody. Welcome, Robert. Oh, hey, Corey. Corey got a little sneak peek that this was coming. He was in a chat that I mentioned this in. So this is going to be maybe, I don't know. We'll see if this works. This might be a bad idea. It's going to be doing something a little bit different. So the plan here is that I want to well, okay, first let me give you the context. So let's see here. This really came about because at Reverse, our conference a few weeks back, Marcus Gastelin, I'll get his name right one of these days. Lights, camera, action. Exactly. Yeah, I've got I literally redid everything as I occasionally do. There's a brand new streaming box that's running, although I need to get newer drivers and switch over different codecs. But it's got a much better CPU, more USB inputs, which is going to be important later. I'll show you why. And I upgraded my Binja demo box because I was literally running on an M1 Mac Mini with like 8 gig of RAM, which is amazing that I could do demos on that, and Binja works great. It's pretty fantastic. But I wanted to do something a little more powerful, so I got an M4 Mini, swapped that out. So like everything has been swapped out. But yeah, so Marcus spoke about full stack registering. Also, let me see. Does this audio come through?
Why is Amazon paying me?
Oh no. Okay, hold on. I don't. Yeah, I'm not logged into my account here. Anyways, we don't really need audio for this right now. I'll look at audio on the audio desktop. But basically the talk, and this was the first video that we put out too. So this is the very first stream that went live from Reverse. I just a few minutes ago put out the next one. So if you go to like the channel, there's now, I think Andrew Roofs is up here live as well. And we'll keep some of the other ones going. But this talk was really moving for a number of reasons, right? It's just a fantastic presentation. Marcus did an unbelievable job. He has spent years doing some really cool reverse engineering on the original Xbox, and he takes you through his kind of his lab, his hardware. It's sort of like the journey of like a software hacker to being a hardware hacker. And yeah, people were like, you don't get to call yourself only a software hacker. Like at the end of this, you were clearly a highly capable, qualified hardware hacker. And he had a really, really touching tribute to Sophia at the end as well. If you haven't seen it, good, just go watch it. I can't emphasize it enough. But it was a sort of, kind of a good call to action too. And so one of the things that I've been wanting to do is to improve my own low level knowledge. I don't think I'm ever going to go to the extent where I'm soldering bond wires onto a CPU the way that Marcus did. But I would love to just be a little more capable. I'd love to even poke around in some of the internals of Miner Ninja that I don't normally do. So I can promise you I will not finish this stream today, right? This is going to be an ongoing kind of series. I'll probably intermix this with some more traditional streams. So we'll see if people like it or not. I want to like set the expectations low though, because I'm going to be learning a lot. I'm going to be messing up a lot. If there's people in the chat that are much better hardware engineers than me, that will be fantastic, because I'm going to need your advice as we go through it. Oof. And Valgrind is also doing some hardware hacking. Yeah, see, I would really like to not go that route. That's kind of my plan. We'll see. I do have spares. So with that, let me kind of get into it and talk about what I'm going to be doing. This started because I saw like a random post on Twitter or something, some social media, that it was talking about this little thing called like a Bitzee. And I was like, oh, that's a really cute little toy. And so I grabbed one. Oh, wait, you know what I didn't add to my control panel? Let me do here. Let me do this. I need to, let's replace this one with overhead. And let's see, is overhead here? Okay, so let's see if this works now. So overhead, cool. All right, so now the overhead camera works. Apologies for the white balance not being very good. This is just a webcam essentially that I'm putting in, so it's not the best. We'll figure out if I want to switch it around, put the nice camera here or not later. But this is a Bitzee, and actually having a bad camera, depending on the refresh rate, is actually better, because you can see. So it's using persistence of vision, right? Like there's literally this little flexible PCB that has LEDs on the very end, and then it's flipping back and forth, right? And they're turning lights on and off. And then there's this swipe sensor, so you can swipe that way, you can swipe this way. You can tap on the head. Donald is my favorite, I think, here. Come on, do something. There we go. Oh, wait, what am I doing now? I can select one of the other things. Oh, that's Pumbaa. So you can, is the audio coming through? I don't know if the noise is coming through in this at all. Then the noise cancellation might be doing it out. But yeah, you've got all these different little characters. It's got an accelerometer. You can move it back and forth. And it just look kind of neat. Oh, sweet, you can hear it. Good. Thanks, Mason. Yeah, and you can hear the flapping. Exactly, you can hear it kind of like, it's like an insect buzzing almost, the wing back and forth as it flaps. And then hopefully you can hear like the music. It's making like little chimes and alerts, and it's kind of playing to me. If you interact with it enough, you'll actually get movies. You get little games you can do with each of the characters. It's very like Tamagotchi-like. So it's a fun little. I don't think I've seen that video before. Let me see. So I can check my star levels here. See, I haven't unlocked the next one. I've maybe unlocked half of these things. There's like 30 different things you can get to. So of course, that's the other thing, is being able to like instantly unlock them would be kind of neat. So these are, I have a star that I can unlock. So this is this previous star that I previously unlocked. This is a fun process. So you tap on it and it says like it's ready to hatch basically. So it's a little like, and you close it. I need to turn off the noise gate because y'all won't hear that. Hold on. That was the best part. Let me see here. All right, so now the noise suppression is off. I apologize. You'll hear a little more background noise, but let's see if I can do it. All right, so that's the normal startup. I don't think that's the unlock thing. So let's go to the unlock again. We go to our book. We go to our star that we've already unlocked. It's interesting how like sometimes the refresh is in sync or out of sync. Okay, so let's unlock this one. And now we've unlocked a new character. I don't know who that is. Oh, it's Goofy. Oh, we got a Goofy. Okay, so now we've got a Goofy character and we can interact with him and unlock more things. Hopefully the audio is a little bit better there. I'm gonna go ahead and turn the noise suppression back on, so it's not quite as noisy. All right, so that's the thing. That's what I'm gonna be looking at, and some of this came about because there is a Reddit Bitzee debug. I forget what it was. It had some. Yeah, there we go. Can the PCB be debugged or resetted? Because somebody was taking theirs apart and had this cool picture of the PCB. They're trying to fix it. It's like $20 on Amazon now. So from my perspective, I don't know if it would be worth it, but it's cheap enough that I bought a couple, so I could decap and take some of these things apart and play with them. We can see we've got like some epoxy covering a couple of these chips. It's not just a bunch of, I guess resistors. It looks like, all right, capacitors maybe. So like I don't know the different thing. These all just look like resistors here. I don't know what these are. This big one here, some pads exposed over here. That little tiny microcontroller or something there. Maybe who knows what that's actually. Yeah. So I could. One of the things I want to do later on is take it. Yeah, almost like caps. Okay, so these are not resistors. These are all capacitors here. And then are these little ones resistors? Maybe. Not sure exactly what they are. Again, I'm gonna learn, so I appreciate the feedback. So. That's kind of our goal. We do get to cheat a little bit though, because if you read this thread, there's a little discussion and somebody dumps, where is it? Somebody dumps bitzee.bin. So there is this bitzee.bin file here that Binja doesn't know what to do with, so I'm just gonna open it as a raw file. I didn't want to map it to memory. And we get this file here. Actually, we can go to triage view. You can see the entropy of the file. So like this already gives us some hints about where things are in memory. Actually, we could even use Firmware Ninja here. And it's not going to work. So I don't there's literally no architecture support. So I don't know if this is going to work. But let's run this. Oh, very cool. Okay, so it does like the entropy analysis, for example, is really useful here. Ooh, thanks, Galen. C is cap and R is resistor. Yeah, let's see. Was that C15, R22? Oh, yeah, almost certainly. That is helpful to label them for you. Yeah, that would make sense. Yeah, Valgrind, you said the same thing. All right, so yeah, but I don't think they're required to label it necessarily, right? But that would make sense. Let's see. Pardon my drink here. I'm gonna drink on camera. So we've got this similar kind of entropy map that exists in the triage view is also here in Firmware Ninja. And so it's made a whole bunch of regions you can look at the entropy between them. Yeah, so like there's relatively high entropy, there's just a bunch of nulls. The green here and the feature map are just gonna be things that Binja thinks are strings, and then it's kind of interspersed, which is, again, this is just all compressed data. So we're definitely going to have to decompress. There's going to be image data. There's going to be audio data. The audio data, my guess, is probably the most of the stuff that's in there. So we'll have to figure this all out. And I've done a little bit of research, but I've done very little. So again, this is where I'm going to be just figuring this stuff out on stream. We'll do it together. So here we go. So this is like pointers, right? So just looking at these values, these are some very different than this compressed region here, right? So this is either code or more likely compressed. Oh, there's this repeated pattern here. This one looks more like code maybe then, if that's like a common prefix in the instructions. That's my guess there. Is it that some? No, that could actually be straight up image data. If you can kind of visually even see it, right? It could also be like an encoded image format. But I doubt that. I feel like they would have compressed the image. I don't know. That definitely has like the feel of image data. No, but there's not enough of it there. Just that little bit there. Yeah. All right. So yeah, we're gonna avoid analog circuits as much as possible. I did take a little bit of digital logic, but that was about 25 years ago, so it's definitely swapped out of memory. And then yeah, here we got like a pure kind of compressed data. So we can kind of look at this and get a sense for what's happening here. But really, without support for the architecture for like the disassembly of it, we're gonna have a really bad time. And this is where, again, I've never created, there we go. So there's some more pointers again, or some table of values potentially right in the middle of here. So we're gonna have to figure this all out. I'll probably be phoning friends and for various parts of this stream. Good question, Galen. What is the architecture? So right now we don't know, right? Like this is exactly what we have to figure out. And so I think that's kind of my goal here is figure out all the research we can on the architecture. If we actually use Binja's open with options feature, we can actually ask it to predict the architecture, and it just says it's x86 16-bit, which we can be almost certain it's not. So we don't know that. Oh, on the block size on the, that's true. That's right. I don't know if that's gonna help though. I think with 128 actually might even be what we did in the last demo, right? The refresh. I think that's just gonna make more chunks of data here. Interesting. So yeah, it sees these regions here that I was calling pointers, whatever. And there's a bunch of nulls in here. It's calling that code because the entropy is a little bit lower. Data. I don't know if I believe this necessarily based on this entropy, but it is a nice way to explore the binary. I don't know. There's a lot of kind of bounces around. It just feels like noise, like this versus this. I think we'd have to fiddle with these thresholds a little bit and playing with it. Yeah, exactly, Robert. So the chip data sheet. So I think most people, your next step now would be to like take the thing apart. Right? Let's pull it. And I did get some sacrificial ones. So probably the next stream I hope to have more like actual like hardware stuff here, and I'll take it apart. I kind of want to get like a that. So I do know enough to spoil it's not a Cortex M. It is even cheaper and more obscure than that, and that's what makes it fun for this particular thing. Is I did get this far off stream. So let's go back to the header, right? Because this does give us a little bit of information. There's this GP3X, and then there's GPC E100A. That may or may not be a string. So if we try this, and again, somebody else has already pulled this image, presumably by dumping one of the memory chips that are on the device, right? Like somebody else got that out somehow. So GP3X, do we see it's a laser? Now this is all like other unrelated stuff, right? So we can throw on GPC E100A. And now this looks interesting, right? So it doesn't have GP3X, so it's just GPC E100A. And that gives us general plus, and there's something here talking about drivers. Yeah, I really need to log into my account so I can skip the ads. So here is drivers presumably for a 128 pixel thing on this GPCEA 100A. Drives 128 by 28 liquid crystal, I assume, LCM, and plays 2-channel audio at the same time. I mean, that's kind of similar to what we're doing here. Valgrind, do you also know the architecture? Are you familiar with this? Yeah, so in general, like I said, I know the architecture only because I've found this previously and I got this far, right? So this is the CPU right here. If anybody else has, like, that's basically the extent of my knowledge. I have a couple other things that I want to run down, but this is what it is. So it's the micro UNSP. You Googled the same thing? Exactly. There you go. So yeah, and in general, like I said, please spoil me. There's nothing here that I can't be spoiled on. We're all gonna figure this out together. And so this is the chip here. It's super nice. Like if we didn't have this in it, this would have been significantly hard to do, right? Then we would be reliant on taking the thing apart and getting some part numbers off it, having to deal with the epoxy. And I think we'll still get to that eventually. But this is the box. And so General Plus is a company that used to be called Sun Plus, apparently, and they're in like a billion devices. And so I did find MAME, for example, actually has a UNSP, has support for a version of this architecture, right? So this, it used to be called Sun Plus, and it's this micro, like what the most ungoogleable name ever, right? Like look at this UNSP. And so but somebody here has implemented a disassembler, or is this is the actual emulator. So something in MAME, UNSP MAME. That's what I already searched for, I think. Okay, so this has been found before, emulating, okay. Unknown SP-based handheld. So they're used in these little embedded toys, and MAME has, oh, Pac-Man Micro Arcade. I'm not sure if that's just related things or not. So the nice thing is here, MAME actually has a lot of work in terms of understanding the architecture. So we should be able to, let's see, registers. Oh, we also do get some information too on the registers over here. So this here gives us a little bit of information about the registers. Where was it? UNSP 2.0. So what I didn't find would have been really nice is to actually get the architecture manual for this from General Plus. Like clearly that's a thing. We could try contacting them. Maybe they would just give it to us, or find it somewhere else. But I did search for a fair amount, and I wasn't able to find the actual specification for the. So there's the data sheet here, which I think that was basically all the data that we had in the first page. So this is just the sound controller, but I think it's again, we saw in the other one that was driving video too, so I think they've implemented everything here. Maybe there's another chip for the accelerometer, or does this have, where's my width? CPU, memory, RAM, ROM. So the good thing is this does give us, yeah, so this is giving us addressing for RAM. Features a high-speed memory with boot code, so it already comes with Valgrind. Yeah, I see you. Test. I don't know when that one was. Oh, is it? Yeah, it's on the stream elements. It should be still working. Real-time clock. Also, I apologize for snacking, but I didn't eat much lunch yet today, so I'm gonna chew some cookies. So we do get a fair amount of details here. The pinouts, which this will be really useful. Hopefully that port encoding is, we'll see if we see instructions that refer to that. We should be able to touch senses input. Yeah, so I think it has a lot of the features that we see in the device. So there may be something else, but in fact, actually accelerometer is one in particular. I don't see anything in here. So my guess is there is accelerometers on that. And test you for good reasons. I'll take your word for it. So I do suspect that we're going to have another chip in there that's doing the accelerometer. Oh, I want to also point out too, on this thread, so someone has already made much further progress than me. Yeah, I agree, Marcus. Exactly. So I suspect that when we get this thing off, it's going to be very difficult to do anything on the board itself. Although, again, so this is Mattis Hemmel, who is probably working on a blog post to do a lot of this RE stuff for me. So I might get spoiled midway through this stream. Oh, there's literally no packaging whatsoever. Yeah, so I actually did try the FCC docks as well, but the problem is because it has no Bluetooth or like there's no actual interference. Your messages with content gets unwritten. Oh, yeah, sorry if I missed the messages, Valgrind. Um yeah, there is no FCC ID. Like it doesn't actually, as far as I can tell, have any FCC registration. So, let's see. So there is some markings here which indicate it's Spin Master. I don't know if that's in focus or not. Spin Master, copyright Disney. It's like the required like toy markings for product safety stuff, I think. I don't know what this is. This is a like a serial number, VO711 APA. The QR code, actually, I didn't think I've scanned the QR code. I think it's just to the app. Let's see. Yeah, it just takes you to Bitzee, play.bitseetoys.com, and then gives you like the manual. And then yeah, so Spin Masters logo again there. Spin Masters is a major toy company. Like I think they're the ones that own Rubik's Cubes even now. They have a lot of toys that they make. Let's see. All right, can I get to that URL from here? Trees.org, die shots. Is this? Yeah, I can't get to that link from here. Oh, Valgrind. Yeah, yeah. Galen, will you make Valgrind a moderator if you can, like another mod? Because then you can excuse me, then you can post links. Or maybe Galen, you can change the settings. But that's true. Yeah, sorry about that, Valgrind. We'll see if we can get that updated for you. If not, I can do it after the stream. And Galen, I don't see which link, or were you reposting the link that that Valgrind did already? Hold on, let me just open it up here. Hmm. All right. So here is that link, the UNSP. Oh, this is UNSP 2.0. Okay, so this is not the exact same one, but it's the same instruction set. Somebody's already done a full scan of it. That's cool. I love chip porn. Sorry, let me go back here and make sure I can still see chat. All right. That's neat. Okay, so I think we're gonna be better. Like I said, I think we're gonna be best off going from here. Valgrind, if you DM Galen in the Binary Ninja Slack, if you're in there, Galen can post the links for you in the meantime. So again, we do have somebody who's ahead of us, and it's fine. It's not a race. I'm not trying to steal their thunder. Where did that link go? It's back in here, right? The Reddit one. Yeah. So this Mattis Hamel has already made a lot of progress in terms of extracting audio. So, and that was 3 months ago. So who knows how much progress they've made. I think they said later on in the thread that their goal was just to get a blog post out, and they were kind of not interested in like some big collaborative effort. Oh, here we go. Yeah, so as I said in another comment, I'd rather dedicate the little free time I have to writing a public blog post. Okay, so here is how they were able to dump it. And then somebody, probably completely unrelated, I'm sure, has posted dot dash URLs. I think we can change that set. Hold on, let me see if I can change that setting. Specifically for this stream, it's gonna be hard not to. How do I do that? Let's see if I can figure this out. It says stream finished. It better not be. Did I finish it still? I don't know why. Oh, right now it goes. Okay, that's just the YouTube UI. Let me see. Community moderation. Moderation activity. Moderation activity will be shown. All right, now let me see if I can figure out how to allow this. Oh, there we go. Okay. Let me see if I can type your handle appropriately in Valgrind. I think I can add you here. Oh, approved user. Yeah, the channel URL of a user to add as an approved user. Okay, so I can add people here. Go to channel. Let's see. Okay, Valgrind, try again. I think I made it so you can post URLs. Fair enough. Yeah, but it would be nice to get you to post links. And again, anybody else that that wants to post links, Robert, I can add you in as well if you're interested, just in case. Let's see here. Oh, where did my custom? No, community. Content, moderation, live. All right, so here, customization, not there. Settings, community moderation. There we go. Oh, that's per user. Automated filters. Well, let's just do this. Okay. I don't know if that was just for this stream or for all live streams. Customization, settings. Oh, there we go. Setting community moderation. I got it. Okay, cool. All right, so I can easily add new people. Oh, URL sent to live chat are already blocked. If you select this option, new comments will be held. Yeah, so I have to specifically whitelist people. Fair enough. Okay. All right, back to Mason has gifts. Oh, Mason, I need to add you. Oh, I can just add you as a moderator directly. Sweet. Oh, okay, I can do this right from the OBS UI. Okay, good. I can add moderators directly. Mason is a gift. Yeah, so let's read here what he was saying. You all might have caught up with me. I wasn't paying attention. So I've done this in order to extract the firmware. So basically, somebody talked about connecting the flash chip externally, and this person, and then Mattis said, yeah, that's exactly what they did. I don't have the flash chip model number in mind, but it's a standard SPI SPI driven 64 meg flash, and the code inside is on SP. A real pain because none of the reverse engineering tools handle this architecture well. Why doesn't that sound like a nice thing to do? Okay, so yeah, that was kind of like the motivation. It was this comment that I saw. I was like, oh, none of the tools support it. All right, well let's get on that. So we're still going to need to figure out like the file format, but we can in the meantime start disassembling, getting like just a basic disassembler, and we should be able to wire up MAME to it. There's one other thing that I found. Ooh, what's Mason got for us? No, go to site, YouTube. There we go. Someone else has some reverse engineering notes and data sheets as well too. Cool. So somebody else did this. Let's go get their stuff. Unit Tapichan notes Gmail. All right. So this one is also. So this is a slightly newer. ESP is not widely supported by the RE tools I have. So somebody else had the same observation 4 years ago. So hopefully this goes well. sound and picture processing. So this is the 101 UA, whereas we have the 100A and GPL versus GPC. Interested. This one is the high end. Is that what the L versus the GPCE? This one is G. This is just the sound control. Actually, I wonder. Either way, whichever one we've got, it's basically still going to be the same specs in terms of the disassembly. They're both UNSP 2.0. So let's see what else we've got on this site. So we've got a data sheet. Oh, you do have a gift for me. Good call. Oh, so it's only 1.1, but that's still very nice. Wait. Oh, okay. Ooh, nice. Now. So Jared, I didn't actually extract the firmware. Somebody else did, and I found a link online to it. So the current, in fact, it's also worth pointing out that there's actually like 4 different models of this thing. So if you actually look for here, yeah, so there's the Disney one, and then there's a couple different editions here. Magicals, which has 20 characters, whatever line this one is. And then like, is this different than the other Magicals? Or is it the same? That's weird. It looks like the same. So I think there's only 3 editions. I have 2 of them myself. And so, yeah, and we did see in that image of the PCB that there was multiple chips that were either epoxied or they don't have a package and they're directly on the board. That's why they're epoxied, just cheaper ones. They're just right on the board. So, and there's also, it is worth mentioning, I found this as well before too. So, UNSP IDE and example code. So this also sounds useful to me. And so I didn't really dig into it yet, but this exists where there's actually an IDE that we can use to write new code. See, exactly, Jared. The Tamagotchi, this is very similar to the Tamagotchi style hacking. All right, so. All right, so we've got our. Now, also, I wanted to. Yeah, I'm going to force myself to use some new tools and try some new things. So Obsidian is out, and I kind of want to play with that. So I'm going to use this for some of my note taking, and I'll put all this repo. I'll make public, much like the other person already did with their work. So that makes things a lot easier. So we're going to create an architecture. I don't know if this is the order we'll do it in. Create a binary view memory for the Bitzee. What I'd really like to do is to be able to dump and flash the chip myself, because I want to rewrite it, right? I actually want to put a little Benji character on it. That's the ultimate dream. Of course, my end goal here is to do that. So that's kind of my goal here that I want to do. And so let's see here. We've got this Windows-based installer, so that's not going to do us much good, but we could set up a VM. And yeah, I actually don't want these. So let's put these in our notes. So so under resources, we've got IDE. I think that's actually, yeah. So there's a IDE and example code lives here, which we've got, but we're not going to commit that to our repo. So maybe we'll make a private folder, and we're going to put these here to not commit copyright infringement. The spec sheets also And we'll keep that also in there, right? That we can link to it. And then let's also link that other repo. There's the main one. I still think we're gonna need that main one too. This one's great though. This one's really good. That's a good find, Mason. Related repo. All right. So let me also do, before I forget, let's make a new Git repo. Let's ignore the private folder. We should probably move the the binary into the private folder too while I'm thinking about it. Yeah, I could. I mean, they're not. They are pretty big. It's mainly the IDE though, and I mean, other people can just download the IDE. I don't think I might. I'll probably create a Binja database for this file eventually, and so that I'll probably put into here. But I don't think I need to link to that. Now this example code. Let's go look at that. So the example code I think is got with a GPCE 100, right? GPCE 200. Others. QPX. Oh wait, QPTX actually has the GPC 100A. So this is us. This is our sound chip, but it also has touch, trigger control. And so let's see. Oh, you know what? I didn't install VS Code yet in this box. So this is still fresh. Let's go grab that. Actually, let me get Sublime. I need to get my Sublime license key out of the machine. I don't have that. But this does have some source code here. This QPCX, is that a... Let's go drag these into applications. Oh, sorry, I missed a few from earlier. Oh, I am going to use Vim. I'm going to use Lunar Vim. But I usually use VS Code just in Vim mode. That's my main kind of IDE. I know, I do need four. I do need more cookies and soda. You're right. I do also have some water, so I'll be drinking some water here too. It's a little bit healthier than the Oreo minis that I'm munching on. Okay. So, oh, the other thing, somewhere in here I found, they mentioned specifically that it comes pre-flashed with the bootloader. And I thought I saw somewhere in here previously a bootloader. Yeah, there we go, boot code, there we go. So inside of each one of these subfolders, is a boot user code ASM, yeah. And so, and in fact, I verified that, like if I do this, nope, not that file, and that file. It's the same ASM file, so they've done it so it's self-contained. Oh, that's a good point, Nom. Yeah, exactly. So I could, yeah, it should make it easier to modify the firmware myself. That reminds me, suggestions, especially if Marcus is still here. So I think I'm gonna want a flash dumper, right? To be able to like do the flash dumping myself. So I need to go buy some hardware before I do the next stream. Actually, what I usually use is, I wasn't, did I use grep in the whole thing? No, I was using find. I was rip grep, also search for file names if I just do that. That's what I said I was going to do, force myself to use different tools, so. All right, let's do it. I think rip grep is contents though. All right. I usually use, where's RG? All right. Files matching. Automatically skip. See, actually, I don't want it though to automatically skip the get ignore rules in this case because like I want them hidden just because I don't want to push them, but I do want them to be what I'm searching for. Is that actually, let's look. So if I use rip grep, yeah, so it's searching contents, right? It's not searching. Oh no, the Bitzee bin is inside the ignored folder, so there's only two. Let's just see, rip grep 2. Yeah, so it'll search for the contents, but not the name. So in that case, I think it's what I wanted, but sweet. Thanks, Marcus. Yeah, I no worries if you're not here the whole time. I did not expect that. All right. So let's see here. Let's go to babies first. Hmm. Okay. So what did they part number? All right. So spy bus request for pins. Bus pirate. I guess that's the with the flash ROM software. Oof, is there a bus pirate with USB-C? All right. Yeah, if other folks who do hardware stuff have more suggestions. Actually, I think I have I have a couple things like in storage from when I thought I was going to do hardware many years ago. One of them is the JTagulator. Does it speak as spy? Specifically for doing JTag and UART. Does it do? It's probably so old that yeah. Yeah, Bus Pirate is probably just what I want to go with. Ooh, there is a newer one, Bus Pirate 5XL. Okay. Bus Pirate V5 hardware. Can I buy? Oh, this is it? This is the Bus Pirate? Ooh. Well, it's USB-C, so it answers that question. V5 and V6. But I'm lazy, interwebs. I just want to buy it. Okay. Oh, it's an ARPI 2350? That's so cute. Very cool. Follow along logic and records every bus action for easy debugging. What's the difference between the 5XL? Oh, the A or the B? Yeah, Project Cube is going to be awesome. Hype for the following the progress. Project Cube? Oh, you mean this hacking itself? Or is there something else? Yeah. Let's see. So what is the difference? Yeah, I mean, I don't think any of these really are going to matter. So let's just get the one. So Dirty PCB seems to have the latest of these. So yeah, I'm gonna probably go grab a Bus Pirate, either the 6 or the 5X. What's the difference between the A and the B? More pins on the B. Okay, it seems better if the price isn't that different. Then yeah, the B is the better one. So the Bus Pirate 6 is the better one. Let's see how much it is. $82. It's a business expense, right? It's fine. Um, maybe I won't. Oh wait, production starts next to you. That's unfortunate. How about the 5XL? Does that? Is that one available? Okay, that's cool. Yeah, I don't think we need the all the pins on this X. Like this is a toy. Thanks, Robert. A Glasgow. All right, what is a Glasgow? Interface Explorer. Oh, it's White Cork. White Cork marketing. Okay, well I gotta support them anyways, so that sounds great. Is this available? Fulfillment progress. A tool for exploring digital interfaces. Oh wow. Okay, can this do spy? Initiating transactions via spy R2C, standard protocols. Program verify with spy. Can we dump AVR with spy? Can we dump presumably like we could if we could do it with a bus pirate. I would it seems like this is designed to kind of be a superset of that. Thanks. Appreciate that, Valgrind. Yeah, Interface Explorer. There's a full FPGA on it, so that's definitely going to be okay. Block diagram. IDs. Oh, there we go. Look, I wanted the comparison. Cool. Okay, so literally everything except for the bus blaster can and tabulator. That's hilarious. Answers my question from earlier, right? Yeah. So this is a nice comparison. Glasgow's says 130 here, but this looked like it was more. That often happens though. Rev C. And one full set of Flywire sync and USB-C cables, and the aluminum case. Whoa, can I just get a cheap plastic one? That's cool though. All right. What is this one? Oh wow, that's an old one. That's pretty neat too. Um, that's a cool looking board. All right. I think we're gonna stick with that. Yeah. So we'll probably grab a Glasgow. Um, all right. Cross out Bus Pirates. Okay. Glasgow Interface Explorer. What else are we gonna have to do? Let's go back to. So we're gonna need Glasgow. Kind of want to get a better. I don't really want the aluminum case, just a plastic case. Surely somebody has one. Actually, we have a 3D printer now at the office that I can play with. So I bet there's a Glasgow. Sure enough, I will send that over to Vector 45, which is what we named the labs. Thousands of dollars? Hopefully not that much. I'm thinking on the order of a few hundred max for this. This is a toy hacking thing after all. All right, so cool. We should just be able to print that. I'll send that to Peter. We're gonna order the Glasgow, which I think will give me all the stuff we need, right? It is USB-C. Does it come with Flywire sync and USB-C cables? What are Flywire? Oh, also orders now shipped. Oh, I think this is a little outdated. Move it there later this month. The the shipping meter is not going out right now. Pre-order estimated to ship 20 days ago. Whoops. All right, I'll figure that out later. Oh, I know what I need to do. I need my back and mouse forward button. Better touch, not better touch. What's the other one? Better mouse. Mac OS mouse back forward. There's a what's the app? Sensible side buttons. That's the one I wanted. There's another one too. That's a more. It's actually I thought was a newer one. Yeah, there's another one. It's a very similar named one. Sorry, diving into like Mac specific stuff here. No, what is it? No, that's not it. There's a different one. Is it the network for this one? Let's see. I think it's a fork of it. Network. What else do we have? There was another one. It's all the same name. There's another. I wish I could remember the name. Oh, I should check this machine. It's on here. Sane side buttons. Oh, that makes sense. Well, we'll see. Maybe I'll just buy like one of the cheaper bus pirates. That's still a little bit like one of the older ones. Just as a temporary thing, and I can also still put the order in for the Glasgow. I don't want just a PCB. I want. Yeah. All right. I'll actually no. Let's figure this out now. So. Okay. So what is the bus pirate 5? This one's available a bunch of places, which generally speaks to it being pretty easy to get a hold of. Oh, thanks, Valgrind. Thawwire is exactly what I want. Yeah, it's this thing right there. Yeah, that's exactly what I need just to be able to either put the headers right on or I can solder something onto them. We'll see. Okay. Oh, yeah, I do have a soldering iron, so I'll bring in all my hardware stuff next time. This is why I had to get the camera for the overhead, although I probably need a bigger workspace, so we'll have to move this around. Oh, thank God, I appreciate it. Let me see here. Let's go look at this. Oh, sane side buttons. Let's go grab this one real quick because I'm tired of not being able to click my mouse button on macOS to go back on web pages. And I will certainly have to authorize it. I actually do have Touch ID, which makes that better. Quit and reopen. You know, it would be nice if you could do all these at once, but no. Okay. There we go. Okay, so Bitwire, which is where we're looking for the Glasgow. Few purchasing options. That should take us. Oh, it's still under crowd supply. Does it take us to? No, it's still cloud. Okay, yeah. So let's do. A bit squared. Okay. Store. Discontinued embedded hardware. All products. Let's go all products. All right. All right, so we're looking for the clips to add to the wires. Oh, Valgrind, your link didn't come through. I thought I added you. I wonder if it doesn't go live right away. Tiger. Let me actually just search there. So Okay, so tie guard. The base logic analyzer. Yeah, a logic analyzer. I'm hoping I don't have to go that route. We'll see. But better to have it and not need it than to need it and not have it, right? So there's a specific JTAG interface, and presumably, is it these the pins that I can just use for this for? Tools for spline interface. Okay. PC byte kits. Yeah, I think I saw that on the other. Where was it? I know it'd be nice if there was a search here. I didn't search for the word byte on any of those. It may not be there. Yeah, let's just do PC byte kit. SensePeak, that's right, you mentioned that. Okay. Oh yeah, the magnetic plate in particular looks really nice there. Oh man, but you guys are gonna run me up into the thousands if I keep going all this stuff. That does look super nice though. All right, I wonder if there's another place to get that. It'll probably delivery 1 to 2 business days. Not in the US, I bet. Whatever, we'll do that later. Okay, so let's put this. We're gonna do the Glasgow 3D printed case for it. Actually, let's turn this into a checklist. Can I do that? Yep. Okay, so we've got the PC byte, got the Glasgow digital interface. We've got let's see. Amazon has the USB-C BitMagic at Mega 32U4. Is that it? Microbit? No, that's just a USB-C cable. Black Magic, that's not what I want. BitMagic. There we go, Logic Analyzer, that's what I want. Okay, and this one though is micro USB, it looks like, or is it USB-C? It doesn't say which. Test hooks, ribbon cable. Yeah, unfortunately, it looks like the BitMagic is. I assume this is the USB-C one. I can't tell from that photo. Oh, you said for Mauser though too. Let's try that. One O is it 10A, which is the other one with test hooks. Non-stock delete. Okay, so the with test hooks is not available. They've got plenty. Beautiful. Okay, so that one looks good. Can I hit here to go to the page? That's 1.1A. Ooh, it's even newer. Man, that's kind of dirty looking. It's weird. All right, so will that take me? There we go. Okay, so we're gonna let's see. Glasgow, PC byte. Let's see, is this a consistent set of stuff that we want? We've got this, we need the, like, what's the PC byte? Does it come with all of the pro? So how does that, so then presumably, oh, that's how you're getting contact with the pins. Where's the other end? Does it, I don't actually see, how does this go into your... Does this actually come with that though? I think it's just the probe needle. Yeah, I mean, hold on. So like, where's the other end of this though, is what I'm saying. Like that comes out there. These are just the other devices that are shown. This is just the plate, the magnets, and the arms, I assume. I assume it doesn't also come with the... I don't know, 130 euros is a lot for just that, but maybe I think that's what it must be. So the user guide for specifications. All right. So yeah, it's the holder, the base plate, the probes. It's pretty cool though. So you can just like crimp and hold. Little tiny probe point. Oh, there it goes. Okay, I see now. That makes sense. Okay. Okay. Oh, and a magnifier. Actually, I want a good microscope too. I don't know if I'll get that for this yet, but yeah, Bitmagic Mouser. Okay, so I've got the Bitmagic Mouser. I've got the, I can use the PC. I don't know if I'll get the PC Byte just price wise. I don't know if I would use it all, but the PC Byte, it's easy. The Glasgow makes sense. I probably should, but even if I just get the PC Byte, I'm going to need some cables. I think I have enough cables floating around from other random stuff that I should be okay. We'll see. We're gonna try it. I think, do we want to go? Yeah, then the case, print, buy. Wait, why is that not? There we go. Okay. So I'm also, like I said, learning it kind of Obsidian here, getting a sense for that, which is interesting. Okay. So here's our tool map. Now, I kind of want to go back and look. I think we have a sense for what we want to get. Oh, did this... Yeah, so there we go. I could also just get the... Yeah, this one is in stock. So I can get the cables. Okay, so I could get the tie guard. Yeah, let me go back to tools. So I can do Mauser's Bitmagic, but then I can get the cables from here. And then I can do the tie guard, right? From here as well. Because yeah, there's okay. I don't, it's not clear to me if I need the tie guards in addition. Is that the interface for it? All right, we'll figure that out. You can find this. Yeah, I mean, I think if I'm doing custom decoding, I would, but I think I just need, like, I should be able to just use the tie guard itself directly to do spy, which is the main thing I need. So I think, assuming the Glasgow is not going to be able to come right away, I can just use the tie guard and the two. So I can do the flywire, the ribbon. Oh, no, sorry. I do need the... Yeah, so this is... The Bitmagic is the one I don't need right away. PC Byte I probably don't need right away. But I do need the tie guard along with these two. Okay. Let me know if that makes sense. We're going to get the tie guard, the cables. That'll give me the... So that should give me what I need to dump spy initially, and then these are some other kind of like bonus stuff that we'll see. And then we've got the case of the Glasgow. If we do that, we can do that as well. Actually, I wonder if there's a... Yeah, there we go. Tiger Dan. Oh, that's a lot of little pieces though in that. It is cute though. This is a remix of it to make the legends more visible. All right. Do that one as well. Absolutely. If I can not have to code, then I mean I code all the time. So, all right, that's our shopping list to go deal with next time. I think we have enough things to go after. So let's go back and back to the problem at hand. So I think I'm just gonna get the let's just see if we can do a couple things. So first of all, MAME has a disassembler and an emulator for the architecture. So just the disassembler alone would be useful. We can wrap that in a Binja architecture, and then just get some basic disassembly out of it and point it at different offsets, and then eventually we can work on implementing our own. We've got yeah. This is for the this is the emulator, but I think there's well, it actually kind of has both. If anybody who's looked at MAME stuff before, it looks like it's kind of a mixture. Like you can both disassemble and emulate in the same package. So NSP, yeah, because this is for emulating, right? Like device start, initializing it, and then adds a bunch of debugging information. So debugging might be a little bit overkill. That's a good question, Robert. I probably want to go with Rust, although I really don't know Rust, so that may be a terrible choice, but that means I can bring in other coworkers that do know it and have them come help me. But if I wanted to do it myself, I'd be better off doing it in C++. Um, so let's look back over this. Okay, missing somewhat similar UNSP-based chip. So there's a programming guide. Yeah, this was in this repo, right? Is that the one that was in the repo? Yeah. Oh, it's a different one. It's not the same one. Oh yeah, the programming guide is online for this one in particular, I thought. Not the CPU specifications, but like the device. Oh no, this is the full instruction to coding. Yeah, okay. Um, there we go. The programmer's guide though, that's an amazing find. I could not find that anywhere else, so that's really good. The instruction says summary. Quick reference for decoding. The tooling for the assembler if you want to test assemble some code. Oh, the programming tool though, does it? So that was like the Windows installer though. Can you just hold on? Let me actually clone this repo and grab this stuff locally. That would be better. So, um, so actually, in one of more things, because I did this last time and I found that, all right, we're going to build MAME in the background because it takes forever. Last time I did this, literally just make. And I don't need tiny, unfortunately, because I need support for that. I think you can do coding standard, just make. Okay. Let's see if that works. And we'll just see what we build if we get standalone. I don't remember if, I think there's a way to like, just use MAME as a disassembler. I think that's That's a good point, Valgrind. So, I mean, I think I can distribute in the Binja plugin manager a GPL v2 plugin, and that's okay. Um, because then users themselves can download it and run it with Binja, but like I'm not distributing it with anything that isn't GPL v2. It would be annoying if I had a GPL v2 my code. Actually, I think I can still release my code under like BSD or MIT, but then obviously the subcode would still be GPL v2 and people would be subject to that. But I think that's actually okay. Um, in particular because I don't ever plan on releasing this with with Binary Ninja out of the box. Like this is clearly a one-off thing. Um, was Mason saying "oh no" because I mentioned pulling in people to help with Rust, or "oh no" because I was considering C++? I could see it going either way. Um, but yeah, that's kind of part of the point, Robert. Is that I do want to push myself. So, like I said, this will be the all right. So here we go. MAME does have a disassembler, universal disassembler for all the architectures. So, uh, does this support UNSP? UNSP? It does. Yeah, so MAME has this universal disassembler also. I think there might even be like literally just builds of it. I could just grab this and see if it comes with the disassembler. Let's try that too. While we're building in the background. And then let's XML. Did I really hit an XML file? What? What? What in the world is this? I'm so confused. I thought I hit the zip file. Wait, what? This is what is going on? I'm not crazy, right? I download the zip file and it's decompressing it already. That's all it's doing. Okay. Yeah, thanks Safari for doing that. I should probably be using Brave or something else. Ooh, Valgrind, much appreciated. You just saved me some effort. Thank you very much. Let's try that again. In the meantime, let's go grab Brave so I can stop letting Safari just randomly extract files that I hit. I mean, I'm gonna run it anyways, so I don't know if it's that big a deal, but I'm really confused. This is literally just an XML file though. What is... I would have... That doesn't make any sense to me. Why is this just an XML file? It's like this giant... XML configuration of... Huh. Okay, well clearly I have not done enough with MAME because I have no idea what that is. Oops. All right, so that's not what we wanted. So if I grab it from here, let's see if it contains the disassembler. This is why we're letting the build go in the background. Regular updated binaries and packages, usually within, yeah, that sounds good. Mac OS Intel, is that all the, do they only have Intel? I mean, I actually don't even have, oh, that's true. I could just install it off ports or Homebrew. Let's see what Homebrew does. If it's already got a pre-built version, we'll see if it contains the disassembler. We can test it on some samples. Actually, let's go ahead and let's see. Brew contents MAME. I forget brew list MAME. There we go. Well, yeah, that definitely isn't it. I need to update my Ghost TTY settings so that it copies every time I highlight automatically. Yeah, it's gonna go straight to this thing, isn't it? It's like this giant static compiled thing. That's not what I want. That is not what I want. Oh, no, I put the wrong file again because I'm still, okay, all right, I gotta fix that. So, Ghost TTY, copy selection. Thanks, Valgrim. Appreciate the help on that. Copy on select causes copy to clipboard to appear. There's a reload setting, reload configuration, so I don't have to. Yeah, there we go. Okay, that's just the behavior I'm used to. I wanted to, yes, please hijack my. Okay, that'll hijack my clipboard buffer. All right, Brew search STL. I probably need the STL. Brew install. No, it's just STL2. I already, I did it, but I bet I didn't. Do I need the specific packages? Let's see. LSD. Try again. STL main. Brew. They're like, just use Mac ports. Yeah, if Mac ports contain the disassembler, I could. I wonder if I could MAME help signal. Is that the syntax? Oh, there we go. Okay. Show usage. Yeah, I still don't think it's going to be a disassembler if it's just this built standalone version. Also, I'm curious, actually, does the default come with a UNSP? Let's ROM sample verify. List devices. Devices in a system. Cool. Maybe that's what that is. Let's see. I don't think the devices are necessarily the CPUs. I don't know their nomenclature for what they consider. STL input options. Actually, I can probably build MAME just disassembler. Like I should need STL if I like don't want the UI at all. Yeah, let's see if I can do that. Was this the one? Where's our building from? It was this one. Regenie is 1 by default, it looks like. Target name. Okay, tools equals 1. Oh, I think those are the defaults now. No OpenGL, OSD. Ah, there we go. So what OSD options do I have? Yeah, I want, okay, hold on. So cd scripts source, cd OSD. Is there like a dummy one? I wonder if there's a way to. By default, we're using Windows now. I'm on Mac. Yeah, without display. Nag or loading screens. MAME without a nag screen, no. Limiting startup screens, no. Everybody wants to build their MAME without nag screens. That's funny. comment directory, write the disassembly. Write the write DRC native disassembly log. Huh, I wonder if, yeah, but it still supposes I have an exact platform. I won't be able to get MAME running because I'm not going to have a full exact platform. Kale, welcome. It's late for you. We're hanging out. We're currently like working with MAME. I don't know if you caught the bits earlier, but we have a Bitzee right here that, if I can get it to show up right, and if I'm talking, you can probably hear the background as it's making noise. So we've got goofy little characters you can interact with, and so this is what we're hacking on. Center it right here. Oh, I've got a message. Doot, tap. Yes, yes, and oh yeah, see my little Wally. I wonder if I can change the. Probably can figure out how to change the camera settings to try to change the frame rate. But anyway, he's upset, so he needs me to like give him some love. So a little Tamagotchi there, and he's doing a thing. There we go. Okay, come on, here, go this way. Yeah, there he goes that way. He's back. Oh, my star meter's full. Oh yeah, I got a new star. Oh, what star is this? It's a red star. He's going to the book. So I can go now to the book menu. No, no. Here. There we go. Let's go to the book menu. And I got my new star. 95. What? Oh, I know what that is. That's cars, right? I think that's what that is. So now that the stars are attached, now I gotta do the shaky thing. If I can actually get a little bingy. Yeah, we can put it on the stage at ICTF. We'll have the little bingy characters walking around doing things. Alright, let's see if it's. Was that right? It is. It's cars. Oh, that's pretty good. That's a pretty good looking image. Yeah, so that's the cars guy. Nice. Oh, that's pretty good sound effects too. So you got a movie? Let's see. You can watch the movie for each character. Oh no, it's. Oh, or see the game. Oh, these are the games. Oh, he does. This one has a game. So the ones with stars on them up in the corner there have a game. So that actually sounds like them. Did I do it again? No, yeah. Ka-chow. Does he do the game? Somewhere here is the menu. Oh yeah, there we go. Whoa. That way? That's probably the most impressive graphics, actually. The animation on the cars are really good. It's way better than most of the characters. Oh, see, someone else is complaining. I've got a text message. My monkey. It's Apu from Aladdin. Which, by the way, very disappointed. Like, super disappointed. It's not, you idiot, we've all got swords, is not the scene that plays when you select the movie for Apu. I was, like, actually upset. So, like, if you do the... Where's the movie? Yeah, I think that's it. There we go. So it's gonna play Apu's movie. Let's see if you can see. He's, what is he doing? He's grabbing. Oh, he's grabbing the gem, the little the ruby scene. So like anyway, it totally should have been you idiots. We've all got swords. Like or at least some allusion to that because that is like one of the best parts of Disney cinema in my opinion. So all right, well there's the poo. Anyway, we're up to another star. All right. So that's what we're hacking on. And we've identified the CPU based on this string. And we've got a firmware dump someone else has put on the internet for us, which is nice. So later on, we're going to dump the firmware ourselves because we're going to have to anyways to get the, oh, yeah, here's the string that we saw that got us a lot of the specs. And so now we've found a few other related things. Mainly that MAME actually has a CPU disassembler and emulator already for it. So should be pretty straightforward to get that building or to get a new architecture for Vinja going based on that. So I'm kind of like trying to get that just main building right now so I can then try out as disassembler and feed it some bytes from this thing and we'll see how that works. So that is where I'm currently stuck fighting where it wants SDL support. But actually, hold on, let me try it again because I did install SDL since this thing. Search SDL. Do I need... Wonder if it's a particular to, yeah, STL2 graphic. Okay. Brew install STL2 graphics. Let's try that, or maybe, yeah, let's see if that works. Oh, no, so there is somebody earlier pointed out, there we go. REG, well, it's not clear to me because this make Regenian tools, do show up as Regenian 1, verbose 1, ignore get, meme, subtarget. Oh, the default subtarget is tiny though. I don't want that. So I don't have to I have to specify that. Is it all subtarget scripts target? Okay, so main scripts sub target. Main, we've got dummy main or tiny. Actually, I wonder if I can do dummy target main file. I wonder if I can just do a single architecture. I'm probably not going to get that right. Yeah, we're just going to try to build it all for now. I've said this before, but much harder than coding is actually understanding a random project's build system. That's way more work. So this is going to do all of them. But we're going to do, okay, let's do that. Mame. Oh, Mason's already like half done with this thing probably in the background. Yeah, no, Mame might not be the play just because it's such a huge thing. All right, let's go see what Mason's got for us. So vSmile is... So here's the 1.2. Oh, I think this looks familiar. Instruction set. Yeah, I mean, I do have enough instructions. Okay, hold on. I'm tempted just to do this in Python too, only because that'll be less painful for y'all. Like there's only so much pain I should inflict on y'all. But it's pretty big. Like that'll be slow if I write a Python arch, but it'll take me a lot less time to do it, so I'm still tempted. All right, let's look at the next one. Mason, do you just want to come in here and do it with me? Yeah, I know it would take several other people much less time. I don't need to do it all myself. Yeah, I think that would be better for everybody's sake if I do Python. Thanks, Galen. Galen, you are a troll and we know it. vFrown. You want to come and hang out and do the thing?
I mean, there's not really much to say.
Just start coding, right?
Just start getting to work.
Why is he doesn't implement OR and test or XOR in
Those
this
are
thing.
yeah, those
Optional
are unnecessary.
things. All right, well we have
There's also a Ghidra.
Wait, what? Oh man.
You didn't get. I sent you the first link. You got sidetracked too easily.
I do get sidetracked.
Never
So
got
in
to
here,
right there.
Oh, that's embarrassing. It does. Ghidra already supports this.
Well, I mean,
is it like a one-off thing or something?
Yeah, but the decomp is bad apparently.
Ghidra processor for UNSP. Oh, there it is.
Yeah.
And there's also, it was forked. Okay, so it was an original one. And then somebody else has a Slay one, incomplete and under development 5 years ago.
Who knows? It's still under development, maybe.
Maybe they are. Maybe they're still doing it. All right, so where did they...
It'll be
languages, C-spec, yeah.
And then the slate.
So what does it got? Yeah, the instructions. Yeah, I should just start writing.
You can get go to one of those CPU. That one right there is probably easy for LLM to translate over.
I could try that too. I thought about
one-shot it real quick.
I thought about like just convert this to a Binja architecture.
Well, I just do the disassembler first and then do it because
like a standalone disassembler.
Yeah, you probably want to do that first.
All right. I'm actually not logged in here to oh wait, what am I still looking at? I don't remember what I've got on the screen. Okay. Let me log into my chat GPT login and then I can just dump that into it. Should I use that or should I use
What has the largest context?
Claude? I think is probably the largest
So
context
we
window.
have an answer to our problem.
Yeah, I should just do that. Okay, let me Claude code command line. 3.7 works real well. I have been a huge fan of it. Don't use sudo. Okay, we'll let that keep going there. Bitzee. All right, so. Oh, actually, I'm only doing it here. I'll do this. All right, let me go get my credentials. I have to remember how you actually have to log into that. We'll figure it out. And then where do you get your credentials? Follow the one-time OAuth process with your console account. Okay. So dev Bitzee arch. So what we're going to want to do is we're going to want to take, let's go take that Geeter arch and ask for a standalone Python. Actually, let's check the license on it too before we, what we got? Something good. Apache's good. Easy. Okay. So let's go get clone that. Was I not? Wait, what?
I would not do the slice spec for the LLM translation.
You don't think it'll do it?
No, because you want a regular like C decode function.
Yeah. So I mean, I could use the main then for that.
Sorry.
Yeah, I could use MAME's emulator for that potentially. You
I
think
would
so?
maybe start off with something smaller.
Is there something similar though? Like
yeah, I mean,
which
any
amongst
of the
these?
emulators, they're gonna have those decode functions. Now they don't necessarily translate to dissimilar, but I feel like those are probably easiest to translate. Um, but there's a few. I mean,
GCC for the source code. I mean, I think I should just take this and feed that in.
yeah, I mean,
Maybe?
I don't know. Maybe you want to do it in processes if you want to get like the table first for the decode, and then try and disassemble.
Let's see. So where was the instructions that summaries is in the other repo.
The reason I say don't do slave spec is because it'll have a bunch of macros that it won't be able to follow through.
Can you all hear Mason? If he's in the background, he was talking. Yeah, I think so. It looks like you're probably a little quieter, but they can probably hear you.
The slave spec will have like those macros that'll follow through, and it's just not going to be able to, I guess, see through all of them effectively with how it defines all the stuff.
All right. Okay, so there's Slay on SP. There's also. Wait, is it the same person? Yeah, it is. Okay. I don't remember if I downloaded this or not already, but that's all right. So the programming guide, I like this instruction set summary feels like the most useful one. Okay, so is that the revision 1.1 of the spec or of the, no, they have the 2.0 ISA here too. Okay. FED Is that the, oh, this is the actual, yeah, it's the full 16 bits, right? So there's the immediates in that encoding. Yeah, like I should just be able to turn this into a decoder. Let's just assume I'm implementing 2.0. Yeah, I'm actually really curious. Let's see if we can actually convert this with one of those. All right, so um, I wonder if I can read a PDF. Can I? My concern is that like the text conversion of this may not come out right. So first, let me. I wonder if I can. I wonder if I can turn this into a machine readable format as one step, and then create a disassembler as another. So let's try that. Let's go. Um, this is page 4 and 5. Well, I guess we should do all of these. Yeah, I need all of these. So 4 through 10. So page 4 through, is this actually, oh yeah, it's also the lies. I'm gonna love that. 10, okay, so 5 through 11. Pages 5 through 11 in that. So Claude. Sure. Okay, now I gotta switch away and we're actually gonna log in here. So no, you're not gonna see my. All right, let's just do this. Oof, that's a lot of Jordan. Okay, so let's log in here. It would have been funny if I put the keyboard on screen and then just go ahead and type my login. That would have been pretty hilarious. I think it's just on my work account, so which usually I try to keep off this box, but well, what could go wrong? Ah, yes, passkeys. This is the best. I don't actually have to log in on this box. Okay. Yes, please. Okay. And interestingly, YouTube is the app that gives me a. Yes. Is this not? Let me see. I'm not sure if that was the right account or not. Claude Anthropic. Hold on. I thought I was logged into that. Let's see. Oh, I am. It's the same one. Okay. It should still be. That should still work then. All right. Let's go back to the desktop. I think I'm logged in now. So let's see. Let's see if this works. Yes. 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 Do I trust the file? I mean, it's a PDF, so I hope so. Okay, so pages 5 through 11 in the docs arch in the instruction set summary. Create a Python-based disassembler. All right, let's see how it handles it. So I've been really enjoying. Yeah, it's a PDF. You need to, yeah, exactly. PDF the text. Does that exist? Brew search. PDF. Okay, brew install PDF to IPE. I don't know, actually, let's confirm that that's what we think it is. PDF to IPE, what is that? Generates an XML file readable by IP. I don't think that's what I want. PDF to text. Let's see. Poplar. Okay. Well, that was a waste of time. Well, we're almost done with all that. I hope. That was a lot. I don't know what PDF to IP. Okay. Yeah, libpoppler. That's the same thing that like Ubuntu uses. PDF. Poplar's already installed. Brew list Poplar. Ah, it's there. Ah, okay. So brew link Poplar. Okay, fine. I'm just gonna put that in my. Actually, here. First. All right. So I should just be able to tell it that, and then there we go. Go ahead and do it. Yeah, so I'm a big fan of the way Claude does stuff, where the new Claude Code command line, it'll like run commands. So, okay, so we've got 3,000 lines of extracted content. I should have also had it. Okay, good. So let's see. So I can't easily convert that back into the table format. So I'm curious if it can, because it might be able to. We'll see what it does. It also might cost a lot of tokens. I might run out of credits here if it's doing that. I wonder if there's a better way to dump a to Excel. It's not quite what I want. CSV probably wouldn't be the end of the world though. That's probably, by the way, my favorite thing about AI is that I can ask. It's a little bit like fuzzing back in the day was like doing vulnerability bug hunting, right? Like I can kick off a dumb fuzzer, and while it's doing stuff, I could go and continue to be functional. So it really just helped me be effective with my time. Here's a good question. Camelot as a table, tabula. These both look interesting. Oh, okay. Yeah, let's do that. And let's go look at the result. Is it still writing it, or is it still thinking what to do next? Okay, so Sublime. Spotify command line version? VS Code has a command line thing. Now you have to. Oops, that's not the right app. Sure, get my weather in Melbourne. VS Code. Oh, we are coming up in 2 hours. I do need to end up here soon, especially because I have to unicycle home tonight. It was nice weather. Is it loading? Did I fail to double click? Okay. I do not want Copilot. No, thank you. Okay, where is the? No, it's under the help menu, I think, right? That's somewhere weird. Yeah, do it. Does it automatically do that? Can I just do it now? I don't think I do. I think I have to. No. Yeah. Has anyone else caught me? You guys are quiet. I know. I told you this would be the more boring one. Let's see. Code install command line. Down install additional components. CLI. Command. Launch it from. Yeah. Okay, there we go. There's the thing I wanted. Okay. Command line. Install code to the path. Yes. And we're back. I probably need to do something that like still has audio. You probably don't need to hear the music, especially the volumes loudly. Yeah, let me know about the audio levels if that was okay or not. It's a little annoying probably to get music when you don't want it randomly. Okay, so now we've got code installed, so I should be able to. Yes. Yeah, it's fine. Okay, so now let's compare this to our table. The real thing is this opcode table, GSI16, encoding fields 1, 2, 3, 4, 5, 6, 7, 3 zeros. So that's not right, right? Like the opcode is, oops, I need to put, I need to get NeoVim support. Because I'm gonna use way too many I think is it up to a recent version? 10.4, that's fine. Brew install NeoVim. Okay. VS Code, trust and install. Major performance improvements, default affinity? I guess. Sure. Okay. Not now. Okay. So can I, let's see. All right, actually, I guess we'll do the whole repo. Okay, so we open this repo. I mean, it's probably fine. All files in dev? No, that's a little much. Okay. Is NeoVim? Yeah, NeoVim installed. Okay, now I can move with my Vim movements. So this is not quite right because it's not bad, but it missed. So what did it actually do for the output? Actually, here we can go look at this too. Yeah, that's super. So I am 16. Yeah, I'm not surprised I got that wrong because it was like, okay, no, but there's still, okay, it should have gotten that. Oh, no, it shouldn't have. Oh my, that is 2, 3, 4, 5, 6, 7. Yeah, there's no new lines in here in particular. I needed to figure out the new lines and be smart about that. That makes this impossible to do. So I don't know if I can still see chat. Are y'all still there? Oh, you know what? I just realized Stream Elements is not there. Did I hit that off accidentally? There we go. Oh, Stream Elements is way behind though. What happened there? Oh, I think it just takes, yeah, it takes a little bit to regenerate. I think it's catching up. Let's give it a second. Yeah, there we go. Okay. Yeah, that was weird. When did that go away? We'll send to give the spec and an example arts module. Now, Robert, does IDA support decompilation? It's funny though that everyone's like, none of the RE tools support UNSP. I think they just meant for decompilation, but now I'm confused then if Ghidra has it too. So maybe they just didn't find that architecture module. That's fine. We're gonna get it all done here. Okay, I like it, Kyle. We should full send. It doesn't work though with that. So I need to get the spec out better. Let me tell it. Well, let's again we can try it. We can tell it. No. No, the extracted. Oh, it already wrote me a whole. Wait, what? Oh wow. Okay. I mean it based on the JSON, it built its own spec and well, I feel bad I made it generate all that. Now I'm gonna throw it away. I should have saved that because the JSON could be fixed. Save that Python, please. Let's not let it throw that work away. That's funny. Yeah, so that's what I kind of want to just do it straight. Oh yeah, Robert, absolutely. Like the IO is honestly the easy part. I don't know how much we're gonna get through tonight, but presumably once I have a disassembler working in Binja, like actually doing the lifting is not that bad, especially for, well, we'll see. I mean, it depends. If there's, I don't know. I don't, so what is this EXT? Memory bit operations, register bit operation. Yeah. But like, yeah, how to handle the divisions. Like some of that stuff will probably be harder to lift. Multiplication, division. I mean, yeah, we'll see. we'll see. Yeah, so like the main thing is just getting something that can handle it. Okay, so yeah, go ahead and create that. Except it's wrong now. Okay, now, the JSON is wrong. Looking at the original PDF, the text export was not clean. All other suggestions include using yeah, Camelot, the Python library, to extract the tables. And let's see if I can figure it out from that. So it even supports a base load address, which we can verify. Actually, we could like so figuring out the actual load address is not a bad idea. Like we could just assume it starts there potentially. That feels weird, right? That oh no, this looks like a checksum, right? So this is a header. It's 512 bytes, and then that is almost certainly just some header or checksum is my guess. That's oh no. I just saw Amy's tweet. She's watching. It's embarrassing when I know that people that are watching me are so much better at this than I am, but that's okay. Like I said, we're just doing it anyways. All right. Yeah, let's try the extract tables. Did it already install the dependencies, or is it put in requirements? Okay, so oh yeah. Make a requirements.txt, please. Dude, I mean, if you're gonna make the stuff, like do it the right way, right? Okay, so where are we currently? We are currently here. I really should start moving this out into a different. Actually, yeah, do that. Okay, that's fine. Pip Python 3. No, easy install pip. Brew install pip. Actually, pip 3. Pip X. Oh, hold on, no. Python. I thought it was. We have a 313. That's a homebrew. Oh, pip's already there. Okay, whatever. Install-r requirements.txt. I thought it was -r externally. Oh, brew install. Can brew work with the requirements? Ah, this is yeah. They've made this so annoying lately. Okay, whatever. Brew install Camelot py open cv python. Can I do these two? Is that the right one? No, no, brew. You're not even close. Whatever. Okay, brew search Camelot. You say you can do Python brew, but then you don't have. Also, wait a minute. Uses Tabula Pi and GoScript and OpenCV. I don't like this. I should do a VM. Okay. That's fair. Okay. All right. So let's clean this up. Let's move this over here. Let's reorg. Oh yeah. What's this? I love this. 64 cents. That's how much the work done so far has cost me. I really like how Claude does that. Bitzee Arch. No, we're gonna just move start.py to Bitzee Arch. Okay. Move requirements over there. We're gonna copy instruction set over there too. The JSON, I think I can ignore. We're gonna have to regenerate that anyways. Okay. So now we're over here, and now we can actually start doing this as a, let's see, pyenv. I should use, maybe I'll use poetry. Yes, I do here. A poetry environment based on requirements.text. Brew search poetry. Brew install poetry. Yeah, I could probably use pipe, but I like poetry, so we're gonna do that instead. Because that's actually what we use in Ninja. Okay. Thanks. I already got it, but I appreciate that, Claude. I mean, cool. Yeah, you can do that. It won't do anything. Oh, also should be Python 3. Yep, you're in. I already got it. No worries. Whatever. That's hilarious. It thinks it. Okay. Oh, that no, you're doing the VM. I mean, no. Poetry is already installed. Yeah. Yeah, just go. Okay. Yes, that's what I wanted. Perfect. Okay, so do that poetry. So we're gonna use poetry to generate our working environment. Oh, I have heard about UV. I did Python UV. Somebody else mentioned this to me recently. Okay. Yes. Yes, let's do this. I've been wanting to use UV. No, let's quit. Let's just do this. Okay. Poetry lock, PyProject, we're gonna get rid of. Get our requirements. Okay, so let's install UV. UV help. Okay, that's a thing. All right, and I wonder if Claude knows how to use it. So, okay. UV init UNSP arch. Oh, right, new shell. UV init arch. Okay, we've got a new. Okay, actually, hold on. UV init bn UNSP arch. It helps if I type full words. That's not the worst choice, Kale, but I'm all about trying the new hotness. Okay, so no, I just need to move everything. Okay, so first one problem, and this is very important to me. I need to have a better shell. Is this or better editor? That's not Lunar. That's not what I wanted. Yeah, I just want LunarVim here. There's a whole bunch of it. No, I'm not gonna do that right now. I have so much muscle memory for how to quit that is killing me. That's fine. Move everything up. Move .python project up. Bn UNSP arch. Actually, this one I'm gonna go ahead and move arch. Bn UNSP arch. And then, oh, what was main doing here? What did it put in there? Great. So now UV. Okay, so how do I do the rest of the UV stuff? Cat requirements. Nope. Readme cat requirements. Where do my requirements go? No. Oh, wait a minute. I'm in the wrong subfolder. Oh no. Wrong folder. Did anyone else catch that? No. Okay. No one saw a thing. Yeah, you know what? We'll forget it. We're just gonna leave that alone. Here. Nope. That was in the wrong folder for some of these. Okay, so this is the right one. Okay. So UV init Okay. I can do that? Cool, I did. All right, readme, cat requirements. Okay. UV add those. Okay. Interesting. It's doing its thing. It's okay. So yeah, similar to poetry's setup then, I guess. But now, okay. Run add rough, run rough check, UV lock, UV sync. How do I now UV run? Okay, so UV run, extract tables. Did it use arc parse? I think it did. Oof. No, I think this is not right. That was too slow. Okay, so hold on. It does use arc parse. I'll go to the end. Yeah. Okay, so the argument is the PDF file, and the -o is the output. Defaults, that's fine. Okay, so I think it was. I don't know if that's gonna work with. I can also do this. I can just to make sure. Let's open the PDF and let's do print just pages 5 to 11. Save as a PDF. I don't like this. That is not helpful. There we go. Dev Bitzee Arch. Okay. Instructions.pdf. All right, so let's just those ones. Now I can do UV run extract tables instructions.pdf. And let's see. Oh, well, okay, that didn't work. Sequence out of range. All right. Let's let Claude figure this out. It wrote it. Okay, so yep, you go run it. And hey, I mean, you wrote extract tables, Claude. That's your fault. No, don't read the PDF. What are you doing? Stop. PDF info? I don't think it's going to help you. I really don't think it's going to help you. It is installed, so sure. Okay, great. Did that help you? 7 pages, right? 5 through 11. Oh, it hard coded that. I should have checked myself. Yeah, fix that. Okay, that's cool. Yeah, run it again. I should have fixed that myself, but let's see what it does. Does it create the... Interesting. So all the tables now, table 1 dot CSV DSI 6. Okay, yeah, that looks correct. That looks very correct. Or at least that's good enough that I don't know about this. Why is that one wrong? So why is instructions? So instructions. Oh, is it not able to handle like the ones that are like that, the jump F, or is it the call that misaligned it? Honestly, I'm wondering if I would have been better off just hand typing out this into like a CSV. Do I think that would be better? I'm not sure if I do or not. but I'm not against just doing this by hand. I kind of want to just do this by hand. Let me see what Claude thinks it's doing with the results here. Oh, yeah, it was stuck on doing an LS. Yes, like you got all the files. Oh. Yeah, okay, but like what did you do for the JSON? Can you I don't think this is gonna work though, because like I said, this just doesn't look like. Oh, actually, wait, this is way better looking. Sort of. Some of these are off, right? Okay, so okay, this is actually pretty close then. This is actually really, really close. All right, so I don't know why F suddenly got wider. Oh, because this one, oh, this one's not commas. Jump F got, this should be the call, 822. Okay, it's a separate encoding with just that. It needs to kind of combine these into one. Yeah, I don't know how it would figure that out. That's fine. Actually, I can probably just manually fix that. So, hmm. I wonder if there is a CSV viewer. Yeah, I do want to install this random tool you suggested. And yeah, open that. And now, oh, that's not as helpful as I thought. Let's see here. Is there a better like CSV editor? That's the one that everybody uses. Oh yeah, that one looks good. Let's do it. Let's try that. That looks neat. Is this gonna work? Wait, why am I not? Oh, this is the wrong repro again. Hold on. Why am I in the? Okay, hold on. This is the right one, right? Yeah, it says okay. Open with VS Code. Oh, trust, trust. We're good. Trust. Okay. Open this folder. Yes, I trust the authors. Oh, okay. Let's uninstall this rainbow thing. Uninstall. How do I use this one now? Edit as CSV in the car. Oh, okay, I could have probably left the other one on. That's fine. Table 1. Edit CSV. Neat. Okay. I actually want a second monitor now. This would be nice to do this. So basically, I think it's, let's try this. Let's drink this here. Let's drink this here. No, I think there's a hotkey to turn off, right? Right sidebar? Yeah. And then I need a swipey swipe. There's no swipey swipe. It's the one thing about them. I guess I could set up a swipey swipe. That's the one nice thing about Macs. Is when I have literally a touchpad just sitting around, I can use that. Your Magic Trackpad is now connected. There we go. Side swiping is really useful. Okay. And now get that. Okay. This is just the line number, I guess. That's fine. I'll take a line number. Like DSI 16, syntax, it's immediate. These we can, I kind of want to just delete. Well, yeah, it didn't extract any of that data anyways. So these columns are going to be useless for us. So we can delete these. What does that mean? You might have unsaved changes. Delete. Oh, Nope, don't sort by that. Okay, hold on. Delete, 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 neat. Okay. So what I really want to do now is, okay, that's coming through. So it's this one is the only one that's off. And then jump F. Yeah, why you no split this, man? And then the 20, this is the, oh no, 21 to 20, okay. I don't know what happened there. That one just failed, that's fine. So this is just 1, 1, 1, 1, dash, oh, hold on. Oh, no, I'm looking at jump F. Okay, that's right. So it's gonna be 8 is the first 0. 1, 0, and then that's a 22, 21 to 16. That should be the same as the other one. So something's all right. Oh, column 14. I was looking at the wrong thing. Column. A, B, so letters. 987. Okay, this I don't need either. These 2 rows are not helpful. Okay. Type syntax. FE. Okay. So for this one, oh, okay, yeah, column. Okay. I didn't have nearly enough ones, right? So there should be 1, 2, 3, 4, 5, 6, 7 ones. So let's go to a 22. Yep. And that's going to be for 2 rows. Yep. 2, 3, 4, 5, 6, 7. And then they're going to have a 0. No. Yeah. And then 0, then 1, then 0. And that's a 22, 21, column 16. Same as the one above it. Cool. Yeah, I mean, when the AI doesn't work, Galen, you do what you got to do. Okay, so that's the last bits, but this one, the other ones have those bits qualified. That's fine. How many? So that's 1, 2, 3, 6. Okay, so this normally would be 1, 2, 3, 4, 5, 6. Okay, that looks good. And this A22 15 0 is everything. Okay, this actually, the rest looks pretty close. Just eyeballing it. IC, ID, SE, 0, 1, 0, 0, 1, 0. 10101, 10101. Yep. Then we've got the RSI, and this should be 1, 2. It's only 3 bits though? 1, 2, 3. 1, 2, 3 bits. Yeah, that looks good for RSIs. Okay, honestly, these are looking pretty good. Okay, so is that the only row I got wrong? A16. Yeah. Okay. I like the results otherwise. I mean, there might be some small bugs, but this looks like a good, clean extraction. So can I just save? Does that work? And then I close. Call, did that not? Oh, what I need to do though, okay, so call actually should be here twice. I need to duplicate the ones that are 2 lines, right? So like this should be call A22 and then go straight into A22. Okay, yeah, so let me go back to edit a CSV. Yeah, so any of these are emptier bits. I just have to duplicate that. Oh no, but that one's, yeah, it's 2 jump Fs, then a jump R. Yep. I like it. Although it looks like something else changed later on. Maybe not. Okay. Cool. And now memory bit ops. There's another one down here. Bit op D memory. Yep. Okay. I think we're good. All right. I am shocked that there are still people watching. It's good to have you all hanging out. This at the end looks like, hold on. Is that right? No, something's not right down here. Hold on. EXTA. No, something's not right here. Hold on. Oh, did it split this table up? I bet it did. Branch JXX label. Okay, it did. All right, so this is 2 tables. There should be 1. So I do need to combine table 2 with this one. Branch JX looks good. Oh, I thought I fixed the memory bit up one though. Something's not right with that. Hold on. A16 is the whole row? Where do we get the offset? Oh, it's a string. Okay, okay. It's the first line. Something, okay, so something, yeah, something's wrong here. So hold on, 28. Oh, did it just read a new line in here? 0 RSI. Hold on, memory bit up. That's from the wrong one. That's from the 16-bit shift. It's memory bit up. Okay, okay, something is wrong here. But I have to run to the bathroom real quick. So, ooh, no spoilers for people. Writing a challenge is the other thing I should be doing in my time. But all right, I'm gonna go to the bathroom real quick. This has been a long stream, and several drinks later, I'll be back shortly. Oops, wrong one. I'm chewing too. I was gonna say I definitely missed riding home at light. It is very dark out. 3 memory bit ops. Okay, so this one. Well, it really should be 4. 1, 2, 3, 4, right? So 1, 2. Why is this one getting line wrapped? This 0. Oh, it should be just split? Yeah, that's not a string. That should be 0 RSI. And there's no more extra lines at all. It should be the end of it. Right? No string. Hold on. String start, string end. Yeah, not string. Okay, so 0. Also, it should just be bit up straight into it. There we go. Bit op M0 RS as the second memory bit op, yeah. Then the third one should be A16 comma offset, yep. And then, yeah, none of these are right. It's just gonna go straight to A16. Right? Oh, no, this is the first one. Yeah, the first one above. Okay, so it's actually, it's 1, 2, 3, 4. 1, 2, 3, 4. And there's no that, no, it's just that, hyphen. And then there's a DN. Has it been doing DNs in quotes before? No, only things with spaces. Okay. So the DN, there's a 1001. 1001. Then there's a bit up M, and then we have offset, and we're done. Okay. Then the next one, yeah, is gonna be the A16. But it's actually like that. Maybe I should be looking this back at the CSV again. Yeah, we're reloaded. I know, I made changes. Figure it out. All right, I'm gonna choose some beef jerky here for a second. So I'm gonna mute the mic because nobody needs to hear that. So there's definitely some bugs here beyond just this though, right? Like I'm just kind of spot checking, looking around. Like MOLS, for example, should be 111 SRSK RDI and then no. See, like what is this? Yeah, either one of these moles are right. It should. Oh no, sorry. It is okay. It is 3. Yeah, I guess it doesn't matter what you put it in. It could be at the end or the beginning. That's fine. It's 3. That's 3 columns big. Hopefully I didn't do anything else. Okay. 0, 1. Yep. And then 0, 0, 0, 1. And then this one is. Yeah, see, it's a little weird. Like this size I, for example, is on the left, right? And then these are on the right. I feel like by convention we should put put them in the same spot. Yeah, I think left align sort of makes sense. And then if you have gaps or multiple cells that they're in, yeah, that'd be the way to go. Okay. Then size I. Which one are we in again? I kind of want to pin the first column. Mul S, size I, then RS. Size I is 4. Yep. 1, 2, 4. RS is 3. Okay. So we've got register bit op, memory. But these are supposed to be the same. They are. And one of them is just A16 the whole way. Yep. Okay. That makes sense. So correct. And then we've got a 16-bit shift. 111. 0 and RD is 3 fields 1, 2, 3. Yep. 1, 0. Yep. LSFT, which is 3, 1, 2, 3. And 1. And then RSI, which is 3, 1, 2, 3. Good. Okay. That one looks good. RATI. 1, 0, 0, 1. I'm just gonna go count these to the end. It should just be all ones and zeros to the end. It basically is 1, 2, 3, 1. Yeah. Okay, then below it is that field. Yep, that one looks right too. RTF. So now base plus displacement. Description OP, which is 1, 2, 3, 4, 1, 2, 3, 4. RDI, which is 3, 1, 2, 3. And then 3 zeros. And then immediate 16 for the whole rest. Okay, yeah, maybe this actually is right. This looks good. It looked weird just looking at the CSV, but like the values are correct, I think, which is better for the code and the LMs, even if it's weird to my eyes. This is wrong. This should be 1, 2, 3, 0, and I think there's only supposed to, no, 0, 0. Okay, 1, 1, 1, 0, 0, DR, immediate 6 lines up. Okay. It doesn't even say 1, 2, 3, 4, 5, 6. Yeah, okay. That was it. There was a little bug there at the end, but it's pretty close. Okay, cool. So let's close that down. And I think we have table 1. There's only 20 more to go. Now, I think let's actually go to table 2 because table 2 in particular is just going to be combined into table 1. Then we're going to delete it actually. All right, so let's edit this CSV. We need to delete the ISA columns. Oh, well, that doesn't look good. Video's back. Look like an HTTP issue there. Okay, so let's delete the ISA columns. Let's just spot check it. We should have 1, 2, 3, 4. Well, that's the weird one. So yeah, so we'll have 1, 2. Oh, we were gonna also delete this first row where it counts the columns. I don't really need that. This though is fine. Line numbers are fine. What is in row 1? Literally nothing. Oh, the 1.1s were in the, yeah, that makes sense. Okay. Whatever. Okay. I could probably nuke this for, what did I do with the other one? Did I keep that one in there? I did, 0, 2. I did the same thing. Okay, that's fine. So, okay, so stack, and we've got OP for 4. And then this RH, I don't know what happened here. Okay. So it should be RH equals RDI. Actually, it should be R parentheses H. I think it's the syntax we were using before. Is that correct? WH, yeah. Okay, so the parentheses indicate the subscript. So we're gonna follow the same convention. So it's gonna be R parentheses H equals RD. I think it's a lowercase I think. That's how we've been doing it. Okay. And that is 3 fields, 1, 2, 3, and then 0, 1, 0. Size sub t. Size sub t should be 4, 3, 1, 2, 3. RSI. Okay. Yeah, there's some extra new lines in there, and that's 3 fields. So really, the new lines are the main thing that we're getting wrong. It's just OP, P. That's the same size, and then RDI. 0, 1, 1, D sub N. Oh, size? Size. Did I do that? Not sure. Oh, that's a cute syntax. At, parenthesis U, 2 bits, and then 1 for our side, which is 3. Okay. Yeah, I can just see a couple more of these are wrong too. That's fine. Oh, you know what? We should nuke this first column anyways because we're gonna join it with the other line numbers. And so let's do that. We can, it already has, yeah, has that there. Yeah, all right, so let's save and close that. So now table 2, okay. 2 DS indirect, I think we did that one already. Immediate 16. So even this one, is this? Okay, no, that's not a new line. Good, it's just wrapping. But this one though is OP should be V, OP, V. And that's RDI. 1, 4 zeros, and then a 1. See, 1, 1, 2, 3. I think that's wrong. Yeah, exactly. 0, 1. This one feels like it got wrong more often. RSI. Okay. It's definitely still faster fixing this. Okay, so this is a good example where we need to duplicate these two for the immediate 16. And then, yeah, it should be everything else empty, which it is. Okay, and now we've got, okay, something went horribly wrong in direct 16. Those two are fine, but now this should be, oh, okay. Yeah, the A16 below is fine, but these are just all one big row. Okay, so it should be like Actually, no, up is itself 4 fields, so 2, 3, 4. And then here would be the RD, I, and this should actually I'll just do it by, so this is OP, V, then RDI, then 1, 0, 0, 0, 1, W, W is single bit, yeah, and then just RSI for the last 4, 3. That doesn't look right. My math, I did something wrong. Okay, what did I do wrong? OPV is 4, 4. RDI is 3. Oh, that's why I just didn't. Okay. RDI was 3, 1, 2, 3, and then it goes here. Okay, that lines up better. Yeah. And then this, you can just duplicate these two. Oops, it's direct 16, same syntax, and then A16. Okay, direct 6, OPP, OPP. Yeah, it just didn't split some of these, I guess. It's just kind of lossy. All right, so direct 16, or direct 6 rather. Okay, yeah, direct 6, OP, RDI, and then we have 3 for that. Yeah, so it's 1, 1, 1, and then it's a 6. Yeah, and that should be all last 6. Yep. 2, 3, 1, 2, 3. There's probably a hotkey to go at the beginning of the line. That's fine. Register looks good. OPP or RDI. And then a 1. And SFTW, which is 3 bits. And then SFC. No, it is X and then RSI. There's only 2 bits and then RSI. Yeah. Okay. This is definitely the tedious part of the stream. That is very, very sure. Okay, so it's just straight all ones up until 5, column 5, whatever, 1, 1, 1. Oh, now it gets it right. Okay. Column 5, yeah, and it's just zeros for the rest. Oh, well, that's the easiest encoding ever. Which one is this? Is this ext code Y? Yeah, I don't even, what does ext mean? External code, external register. I'm not sure what that means there. I mean, that's, you know, it'd be interesting actually. So that one we can literally just pull out. No, it'll be that. FFC7. I wonder if we actually have any of those byte sequences here. We do. Maybe not aligned though, so I'm not sure I'd buy that. Unless it's a little, I don't know what the ending is actually. If that's the instruction, maybe it is. Oh, that's interesting. That pattern appears. Whatever. Until we get an actual. See, yeah, but this doesn't look like opcodes here. I don't know what that is. All right, let's just keep going. So ext register. My PDF ads. RA. OP. P. Yeah, you know me. Ext register. RA2. Oh, that's okay. Oh, that's why some of those had new lines. Or had, yeah, the quotes wrong because they were doing new lines. Okay, so it's RA parentheses 2 dash 0. I don't know if that's the syntax I want to go with. I need to normalize it, whatever I do. Yeah, I'll probably just go with that. Subscript and a subscript, basically. And then this one is 3 bits. And then this, yeah, RA3. And 000 RBI. ext push. Oh, did we miss ext code needs duplicates? Yeah, ext code. Oh no, it doesn't. It doesn't need a syntax. There's no syntax because it's literally just a self-contained instruction. Ext code y, whatever that is. All right, ext push pop. This I don't like having to reproduce here. Let me actually save and go back to the. Okay, it detected the save that I saved did. Okay, I was afraid I was going to lose changes there for a second. All right, this one here. I'm just going to do it this way. Push R H comma R sub L to RBW equals 1. Yep. And then we're going to have a new line of pop RH to equals 0. Okay. Let's see if we can just put that in there that way. No, that did not do what we wanted. I guess we'll just do it as a one-liner. Can I edit this? Yeah. Okay. That works. Oh, you know what? That's funny. It got this one perfectly correct. I literally could have just copied and pasted the XCMMM. Oh no, but that's different. Oh, hold on. Did I actually overwrite that? AC push pop is right. Why is... Yeah, I must have accidentally overwritten this. So XCMM is RA equals RB op intermediate 16. Okay. All right, let's finish the XC push pop. Halfway done with this table. W single bit size T 3 bits. R sub H equals RX sub I 0. Just how many bits? 3 bits. Yeah, 1, 2, 3, 1, 0, and then RB I to the end. Okay. Next one, just eyeballing. It looks kind of like it's right. XC media 16, almost. PV. Is that right? Hold on. What am I looking at? E media 16. No, it missed a line. Why does this say 2 minus 0? Oh, this one, RA. Okay, no, I was looking at the wrong one. Op. Okay, RA sub 2 minus 0 sub I. Are we writing Lisp over here? 3 bits and then 1 bit. It's just RA sub 3 sub I. Okay. 0, 1, 0, 0, RB. Yep. Okay. Next one's just immediate 16, and we need to duplicate that whole row. Okay, and now we got ext 16. That one I got correct, it looks like, which is nice. And then it completely blew all of this. So, okay, that's fine. Just OPV RA 2 minus 0. Oh, no, hold on. OPV is how many bits? 4. 1, 2, 3, 4. And then we have RA, which is 3. And then RA3 I 0, 1, 0, 0 RBI. So 4, that's 4. Okay. Next one's an immediate 16, or A16 rather, but duplicating these two. Okay, ext ds direct, another one that looks like it blew up somewhere. OPP. R x sub I. This is indirect, right? Okay. R sub I 0. Hold on, 3 bits. 1, 2, 3. 0, 1, 0. Yeah, this is where I need it. Okay. You can tell from the height of the line that it was somewhere along here. D sub n is a single, and then we have at u, which is 2. And then we have ry sub I, which should be 3, 1, 2, 3. Good. 3 more to go, and they look pretty close to correct. OPP, and then RX sub I. Actually, I should just copy and paste that. I think we're done. Okay. 1, 1, 0, immediate 16. 0, 1, 1, A16. Okay, those are right. So just copy RXI, RXI, and OPP, OPP. Whew, okay. So now save and close that. Let's close that. So I think type syntax FPD. Okay. Yeah, let's say that one is empty. Actually, let's just remove table 2 now. Delete. Yes, move to trash, please. Now, let's just eyeball this. Looks like we have our opcode table. Cool. Okay. Now we're going to try the AI again. Hopefully that's the most manual stuff we have to do. No, I don't want you to search for that. Actually, let's go. We do have to look real briefly at the rest of the tables. So let's. I feel like it's probably going to be able to like figure out these as long as there's no obvious. Yeah, this feels like. Oh, there are labels for these tables though. That might be missing. No, okay. A. Oh, yeah. This is table A. I do need to name them differently. Okay, so the fur one. Yeah, let's rename this table A. Table A. Because I think that's how they're going to be referenced from here. If I had to bet that parenthesis A, it's telling us which subtable. WI, let me see, do we go down to W? Q, T, U, V, W, yeah. Yeah, so we need to name each of these tables accordingly. So table 4, which is table B. Is there a hotkey for renaming? R. I guess I click here and hit R. Table B. Table C is int Q. Is that right? Int off. Yeah. Table C. Probably could automate this, but I kind of want to eyeball them all anyways. Table D. SecBank is table E. E. FIQ is table F. RQ nest is table G. RSDS. Okay, that's fine. It's table H. That was nice. I was about to name it G and it caught it. Actually corrected me. Yeah, that looks pretty good. Oh, table I. See, this is why we're doing it by hand. Yeah, because these actually are continuations. I'm just gonna actually make this 15, 16 here. Is that right? Yeah, that is right. These are padded out a little bit earlier. Okay, so that's correct. So that's actually table I. Table I, and then this one we can delete. Yep, please do. Okay, now J is pretty simple. Okay. I mean, sure. I think it's doing weird stuff with the headers, but it's still going to parse the CSV correctly, if I bet. Which one was this? This is 14. K. So this is K. Syntax, U user. Okay, so the contents are basically here. I'm thinking about taking off the supported column since I'm really just building this for ISA2. It's fine. We're going to leave that one alone. It's still understandable, I think. Okay, so that's table K we decided, right? Oh, what did I... Oh, did I just change that? Okay. Forgot to save that one. Table L is just a bunch of numbers. Why is size? Okay, that's fine. Sure. L, table M. Yep. Oops. Sure. Table N, that looks about right. Ooh, all right, I'm gonna be closing down here soon. This is tiring. Actually, I've waited long enough that I can get a ride home from the office. My wife is working this evening. Um, Table 18. Okay, that's table O. Oops, typo. Table O. Table P. Is that? That's the same table. So I think these next two are gonna also have to be joined. Oh, what did it do here? Hold on. First verify table O. Yes. Yes, that looks right. Let's verify that. Yeah. Okay. Table P though is weird. Like, what is this? What is this? Oh, okay. Oh, it did put it all into one. Interesting. Okay, so it did the right thing. Or rather, just it ignored that context. Do we need this? Maybe. I feel like I should kind of just put it at the beginning and then just see if the LM could figure it out. It got that table contents though pretty good. That's nice. That's important. So this is all of our or our comparisons rather. Um, hmm. I don't know how I want to annotate that. Let's try it without it for now. That's a little hard to parse anyways. All right, so it's table P. Table Q actually goes to the next table. Let's see if this combines this. So less than equal. Yeah, it didn't do that. Okay, so this one. Oops. It's actually like Vim commands to just do the next number in the series, but it would take me more time to remember it than it would just to do that. So there's 20, which is actually table Q. Table Q. And then we can delete table 21. 22. Oh, wait a minute. Did we get that? No, that was it. That's right. That was it. Okay. Forward jump, backward jump. Yep, that looks like table R. Did I typo that? R instead of 4. Okay. Push pop. Encoding there. Table S. T. Okay, it'll register counts from right hand to left, right, RH to RL. Okay. What happened? Oh, we just missed one. Okay, so what we need to do is make a new table S, or table, yeah, T. Yeah, let me, no, there's no registers in there. Table T.csv. Actually, I'm going to call this table T.csv, table T.text. I wonder if I should do something like that with the P as well. But let's just go back and keep going. Table U. This should be table U, I believe. Yeah. Table U. V combined. Okay, nope. V is self-contained. Nice. Yep. Table V. Oh, no. That is part of table V, isn't it? Wait, what is this one? Hold on. Yeah, that is part of it. That's annoying. Where did we do? This one was also, okay, P was the other one that was like that. So this one has, V has like 2 tables in it with different contexts, and we just have to combine it, I guess. Okay. So we're gonna go in table V. I don't know what to do with the, yeah, like, I don't know what to do about this. I'll just put them all here in table V and let it sort it out after it. If it parses this to like the LLM, it'll be fine. I don't think it'll care. If it tries to write code to do that, it'll have to fix it, but that's fine. So that's, yeah, let's delete that one now. Table W looks right. Table X. Okay. So we have all of the tables. Yeah, they stopped just shy of Z, didn't they? Just didn't have to deal with that. Okay. Okay. There is a table Y. Table Y.txt. Like tables, but that's okay. Text hints. Okay. So that should be enough. Let's see how it does. Let's just reprompt it. Yeah, maybe. I don't know. I can never tell like which models are good with like images and which ones aren't. It might have been better. There might be some information in the actual, not this file, but let me go back to the other. No, we can nuke these two. These are left over. So the programmer's guide has a bunch of other text on stuff here. I just don't know if that's too much context for it. I kind of feel like it is. But it like, yeah, like this is gonna be too much, I feel like. Oh, this isn't bad. Code width. Wait, was red F not? No, it was still 16 bits, wasn't it? Totally was. Hold on, let me go back to our table one. Red F. I do like this CSV view. This is nice. Red F. Yeah, I mean it's still 16 bits. I mean, although it is a single. That actually would have been a better sequence to look for than that ext thing. Just for kicks. X0B that. 9A90. Actually, let's do this. Just for kicks, if I look for 9A90 I get 34 references. If I search for 99A, I get 325. So yeah, I think that actually tells us the endiness. And we probably could have just looked at that too, right? And gotten the endiness from it. Because that is our return instruction. And I expect that to be pretty common. So, and this looks like maybe instruction padding. This FFFF 9A 90. Anyway, all right. Well, let's see if that's enough context. If we can get just our basic disassembler working on the first stream, that would be amazing. I would be shocked, but all right. Let's see. All right. I need like a food button I can just put on it that like mutes me. And actually, I think I can do that. I could totally combine that in the Stream Deck. There we go. Okay. I mean, oh wow. Okay, so is it editing the JSON file? It looks like it's just editing the JSON file. It was already there and fixing it up based on those table values. I don't even think I told it about the JSON file. We'll just either remember, but yes, I want to make that edit. Well, that's pretty good. Okay. I mean, so you claim. Let's, all right. Let's see. Let's spot check it. Let's go look for red F. That was the easiest one, right? I mean, yeah, opcoding fields. How are they doing fields? Okay. I have no idea if this is going to work. Let's give it a small little bit of what we think might be disassembly. And then let's also confirm the endianness. Run the assembler. Oh, good. We can do it either way. Default is little endian, but you can do a big endian. Okay, so little endian. Um, all right, so XASM 16 in the DOS command line. That's a tool. Yeah, I do want to eventually get the assembler working too, and then we can that's the other way we can validate this stuff. Probably have to get a VM up and connect into it. Okay, so is that Indian? It doesn't say anything about the Indianness and the programmer's guide. This feels like a thing you might want to mention. um, okay, so for general, for secondary, for system, and 8 extended. So let's look at our JSON and see if that matches. So PC. Wait, oh, opcode. Find PC. No, I want case sensitive. Okay, here's the encoding. SPR1024, BPSR, and PC. That matches the instruction register, which stores the current instruction. Fetch from the instruction bus. The decoder can. Huh. Do we actually get any stuff that operate on IR? No, nothing works on the IR directly. That makes sense. I don't. Okay, the shifter, which can ALU multiplication. I mean, it's hard to say, but yeah, like the JSON looks all right. So I kind of want to just let's see. I wonder if I can get some. It would be nice if I had a little bit of like verified opcodes because the problem is if I just try to grab some random bytes from here, who knows if they're real opcodes or not. Well, I mean, like, okay, I guess we can just do this. Let's go grab that FA90. Or was it 90? Yeah, 909A. If I just do this, and save that as it's not that one, is it? That's the old one. It's the old one. It was called Arch. Yeah. Here. We're going to save it into here, but not over one of these files. We're going to call this shellcode. So can we Python? No. UV run. Oh, I don't need a UV anymore. I can literally just Python run it. I only need that for the extraction. UNSP disassembler, right? Python 3 UNSP disassembler. JSON SP instruction set JSON. Standard out's fine. Base address of 0 is fine, and then the binary file to disassemble. Okay. On SP input file. No such file. Oh, is there no such file? SSD? Oh, Oh, right. It'd be sc.csv sc. Okay. I mean, that that looks good. It said it twice, which is a little weird. Let me just take a bigger blob of stuff around here and then see what it shows up as. Let's open that as the actual file name. Oh, no, I didn't really want that. I just want the hex header. Okay. 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 So either this is not shellcode, or I mean, yeah. So that's the problem is I don't know where I'm, randomly grabbing files in. I think, yeah, I have not tried Cursor yet. I should actually try that as well. Probably use ARD with Claude as a whole. Yeah, that would be nice. So okay. Yeah, I just don't have any confidence that we're necessarily doing it correctly. So let's just look real quick. So 9090, we were going to manually decode that just to verify, because that ending, this shouldn't be an issue with that. All right, so 90 would be that's one nulls OPP. Okay, so P table, Q table, S table, P. It's all zeros. Oh no, is it one? Hold on. No, it's a one and then zeros. One and then 8 zeros. So it would be all one. It'd be XOR something potentially. P. How do I tell the difference between the P? Let's see. Where's the encodings? OPP. OPP. How do we know? Oh, that's weird. So the actual instruction is encoded here? Wait, no, that doesn't make any sense. I kind of need two copies of the thing side by side so I can. So the direct 16 register PI. Yeah, I mean, it is at least in this space where. Okay, so actually, OPRX. All right, so these are all either VI or PI. Yeah, PI or VI. So P, table P would be XOR, and then I would be 001 for RSRD, RARB. Hold on, RSRD, RAB. Doesn't make any sense. Which is it? Yeah, I don't know that I fully understand this encoding then, because this is, oh, our source and destination. Oh, yeah, okay, source and destination for those. That makes sense. So it is just the register. I is just the register table, right? Yeah, exactly. Okay, source and destination. But then A and B are A and are B. Yeah, but so this binary is not what I need to do now. Okay, I think I'm gonna close up for the night. This was a very long stream. Thanks for everybody that hung out. I am going to next time we resume, I'll hopefully have the hardware we can play around with that if we get too boring. But we'll also I want to get the assembler working so we can just test some little tiny shellcode bits. We can write some assembly, assemble it, and then verify the results, because that'll be another really good way to validate our disassembler. So we'll see what needs to get done to do that. But I'm very happy with our progress. We might have a disassembler. It's not clear yet. We certainly have the start of one, and yeah, we can keep working on it next week. So thanks again. Thanks folks that hung out and chilled on a very random stream. Look forward to. Oh, you know what? I didn't realize I didn't have my right background file. need to set that up still too. Yeah, I'll go ahead and probably put this into a Git repo and then tag it for this week's final progress. So we can just push tags every time we have a new week's worth of progress on it. But I mean, I also could have just done something wrong, so that could be it too. But all right, my kids are calling. I'm gonna head out. Thanks everybody. We'll catch y'all later. See you.